Hello students, welcome to Power Tutorials. So today we are going to discuss part 2 of Science Class 10 NCERT, that is CBSE board, chemical reactions and equations. In the previous video I have covered part 1. So in the part 1 I have discussed about what is chemical reaction, what is chemical equation. Among this what we have word and symbol equation, how to balance chemical equation. We also covered what is difference between physical and chemical reactions and what are the characteristics to identify whether the chemical reaction happens. And also few examples we have covered, like for the chemical reaction equations. And then we have discussed about symbol equation, conservation of mass we have discussed, why it is important for the balancing of chemical equation. And also we have covered two questions of in-text questions as mentioned here, that first one and the second one are been covered, and the remaining, as I mentioned, those I will cover in the live session. Once all these parts are done, I'll prepare a live video, and that live session I will completely I will not write in that video, I'll directly go through all the topics and I will complete the exercise as well as in text questions that I will discuss in the live session. So let's continue with the today's part, which is part 2. So the agenda of part 2 is, the first topic we will write the symbols of physical states. So as in the previous class we had discussed about how to write the balanced chemical equation without any symbols. So symbols are important, like symbols of physical states, like it is solid, liquid, aqueous, and we'll discuss. And then we'll start with the top types of chemical reactions. Among the first one we'll discuss combination and also discuss few examples, and then we also cover about what is exothermic and what is endothermic reactions, and if time permits we'll also cover the decomposition part as well today. So mostly I want to prepare a part such that it will only be around 30 minutes, not more than that, so that it will be crisp and clear, and even for your revision it will be useful for you. Okay, so let's start with the first one, which is writing symbols of physical states. Writing symbols of physical states. So what are the physical states present for a reaction? Are 4. So what are those? First one, S. Let me change the color. S for solid, L for liquid, G for gas or vaporous state, and we have last one, which is AQ. AQ means aqueous. So what is aqueous? Aqueous means something dissolved in liquid. So if anything is mentioned something like HCl is dissolved in liquid, then it is aqueous, and NaOH dissolved in liquid, then it is aqueous. So if anything is mentioned dissolved in liquid or dissolved in water, it becomes aqueous. So aqueous and liquid, don't get confused between them. Liquid is the pure liquid, whereas aqueous is something is dissolved in liquid to form a different state, which is called aqueous. Okay, so we'll also cover the example now. So I will cover one of the question in the in-text questions, because they are clearly mentioned. So third one first I will discuss now. Second, as I mentioned, I will cover later. Okay. The first one, what it is saying, solutions of barium chloride and sodium sulfate in water. You can see here in water is clearly mentioned. So sodium sulfate, now it is in aqueous state. At the same time, solution of barium chloride, I can say it is liquid state. Okay, so sorry, let's continue. So solutions of barium chloride, it is mentioned, so barium chloride dissolved in liquid, so it is also aqueous state, and then sodium sulfate in water, so it is also aqueous state, reacts to give insoluble barium sulfate. Okay, we have one more state which is called precipitate P. Okay, so for solids there is no need for any representation, whereas for liquid we have to, okay, for liquid also no arrow. For gas we have to represent upper arrow because it is in vaporous state, and we have a one more which is precipitate. we represent it as P. So how it is present means insoluble in water, insoluble in any fluid also I can see. If any substance is present which is insoluble in fluid, we represent it as down. Down arrow means it is a precipitate. Okay. Soluble in water or dissolved in water is aqueous, but which is not soluble in water, we call it as precipitate, we represent it as down arrow. Okay. Let's solve the question which I mentioned. What is the question? Solutions of barium chloride and sodium sulfate. Let that part again here. They're saying that solutions of barium chloride and sodium sulfate to form insoluble barium sulfate and solution of sodium chloride. Barium sulfate plus solution of sodium chloride. Okay, so now we have to write in terms of equations. So first let's write the symbols. Barium chloride is BaCl2 plus sodium sulfate, which is Na2SO4. Then insoluble barium sulfate, so barium sulfate is BaSO4, and NaCl is I will write the symbol directly, NaCl. So let's balance this first. So you can see here sulfate is 1, barium 1, fine. Sodium and chlorine here 2 are present, but here it is only 1. So simple, if I keep 2, it will get a balanced chemical equation. But they are also asking states. So barium chloride, it is mentioned solution of barium chloride, so it is aqueous. Na2SO4, I think in the question also they mentioned it is dissolved something. Let's see how they have mentioned. Sodium sulfate in water, yes, this is also dissolved, so it is also aqueous. Insoluble, so this is precipitate as a solution of sodium chloride, so that is also aqueous. So this becomes Na2SO4 is aqueous, BaSO4 is precipitate, but it is also dissolved in water, but it is insoluble, so we can write aqueous, but you have to write it as down arrow as a precipitate, and NaCl is again aqueous. Okay. Let me just cross check if it is solid or liquid. Okay, so it is called S only because it is it is not soluble in water. Okay, so this is a balanced chemical equation where barium chloride plus Na2SO4, which is sodium sulfate, gives rise to barium sulfate and sodium chloride. Okay, so in this way we can define the states of chemical equation, and as I mentioned, you have to write the states only after balancing the equation, because balancing equation is the main priority, and then go for the solution, which physical state that particular compound or element is present. So let's go to the next topic now, which is types of chemical equations or types of chemical reactions. So total we have 5 types of chemical reactions. The first one is combination, second is decomposition, third is displacement, fourth is double displacement, and the last one is oxidation and reduction reactions. And we also have one more, which is as a subtopic of this too, which is redox reaction. Okay, if combination of both this happens, we call it as redox. Okay, so we'll cover each one in detail along with the examples one by one. So let's study about first one, which is combination. So the name itself, it is, we can understand that it is combining something to get something. Okay, so by definition I can simply say, if two or more reactants, means the left side of the reaction, combine to form single product. Okay, so what is the point here? This is important. Two or more is important and single product is important. So simply I can say that sum A plus sum B has to get combined to get product of C. So this is generic. With help of examples we'll cover, and you can also understand what is exothermic as well with respect to combination reactions. Okay, so let's read the few examples of combination reactions. So first we'll cover the ones which are taken in textbook. The first one is CaO, which is slaked lime, plus water. If combined, it forms CaOH twice. You have to remember the names. This is quick lime. CaO is called as quick lime. H2 I think everyone knows, which is nothing but water. These two gets combined to form slaked lime. Slaked lime is CaOH twice. So what is solutions? I mean states. CaO is quick lime, which is solid. If combined with water, it is liquid. CaOH twice is aqueous, so it should be AQ. And then all the combination reactions are exothermic. Exothermic I'll explain. Just understand that as of now it is producing heat. So let's understand in detail what is combination. It is happening. Two reactants, which is CaO and H2O. Two reactants are getting combined to form a single product. Heat is not a product, it is just a form of energy. And the product is only one, which is slaked lime, and we call it as calcium hydroxide. This is calcium oxide plus water gives rise to calcium hydroxide plus heat. Okay, so this is one of the example. So where we are using this slaked lime means we are using this for whitewashing. So I hope everyone knows what is whitewashing. So whitewashing, what is will be happening? There will be a wall. So you might have seen during constructions, what we'll do is there will be a wall, and after this on it there will be a cement coating. Okay, I will use this color. Change the thickness. What they will do is they will paint it with cement, and after cementing, what they will do, they will, if you ever notice how they will perform is, they will take a beaker or in a bucket kind of thing, and on inside this they will drop a powder. The powder is nothing but CaO, which is calcium oxide. So this CaO they will combine with water, which is H2. So CaO plus H2O, if they combine, what it will be forming is CaOH twice will be formed, which is nothing but slaked. Okay, so the whitewash powder is nothing but CaO, and this powder they will mix with water to form CaOH twice, which is nothing but slaked lime. So this slaked lime they will apply on walls. So now the cement has been done. Now this slaked lime is being applied on the walls. So I'll just use white color now. Now on this they will apply white color, which is nothing but CaOH twice. So now, but we are applying white color, but it is in the form of a liquid state. CaOH twice is aqueous. Okay, so now this aqueous has to again become solid, then only we can clearly visible the white color on the wall. So how that is happening? So that I will mention here. So what will happen means the CaOH twice which is formed, and we also have a gas called CO2, which is carbon dioxide in the air. So after 2 to 3 days, it will take at least 2 to 3 days. So after 2 to 3 days, what will happen means this CaOH twice will come with the help of CO2, it will convert into CaCO3, which is nothing but calcium carbonate. And so this is forming CaCO3. Okay, and the remaining, which is nothing but H2O, will get evaporated because it is a water, and due to heat slowly it will get evaporated. So by itself, if you just keep a water outside on the wall, or if you leave it outside, what will happen after some time? The water will get evaporated. So what are the water content which is present inside it, it will get evaporated. So this is nothing but whitewashing. So this is, in this way, if you understand, then you will easily remember the combination example, which is nothing but a whitewashing example. So what is happening in the combination reaction in the daily life, this we can see properly, because for any whitewashing, so I think you might have known that distemper and various types of paints are coming, but whitewashing is a general. After whitewashing only, generally prefer to paint another coating on it. So how the whitewashing is being done? It is done through a reaction, chemical reaction process called combination type. So it is happening, quick lime powder is getting combined with water, which is liquid. So these two will get combined. What it will form? It will form slaked lime. So this slaked lime, if it is applied on wall and if kept open for 2 to 3 days, what will happen? The carbon dioxide which is present in the air gets reacted with the calcium hydroxide which is present on the wall to form calcium carbonate, which is the silvery white or the thick white color. Okay, so the one of best example is calcium slaked lime, quick lime getting converted into slaked lime. So this is first example. Let's see another example as well. Example 2. So these are easy examples. I can say the coke, if combined with oxygen, gives rise to CO2. So coke is not the drinking coke. Say the coke I am talking about, the coal form. Okay, this is a carbon. Carbon, if heated in the presence of oxygen, what will happen is it will convert into CO2, and it not only CO2, the main advantage for this reaction is heat. Okay, and then one more example, hydrogen, if it is getting heated in the presence of oxygen, what will happen? It also converts into water. Let's balance this, 2 hydrogen, 2 oxygen, but it is only 2, so I'll keep 2 and 2 here. Now I can say it is a balanced chemical equation. Okay, so and here also heat will be get released. Now let's understand why you are writing heat here. So here I think, yes, here is the water, but heat will be very less. Let's see for other one, which is the first reaction, quick lime plus hydrogen. Here also I mentioned heat. So why you are writing heat? Because for any combination reactions, all combination reactions are exothermic. All combination reactions are exothermic. Okay, so what is exothermic means? Energy will get released in the reaction. So we'll write two, what are exothermic and endothermic. I don't say much differences, but let's understand it. Exothermic, and second is endothermic. So exothermic means energy will get released during a reaction. I'm writing it again. It is energy, not only heat, because there can be any form of energy. Heat is a form of energy, but energy is not heat. Okay, energy will be released in the form of, it can be in the form of heat as well. Example I'm writing here. And sometimes light is also a form of energy. Okay, so what is endothermic reaction? Energy has to be supplied. Energy will be released here, but here energy has to be supplied to perform a reaction. Okay, so where energy is supplied, but here energy is released. So released is exothermic. If you are supplying, then it is endothermic. So here also energy supplied can be in the form of heat, light, and also current. And this is example for decomposition reaction. So when we are covering the second part, you will understand the endothermic reaction in detail. Okay, so just now, right now, just understand that endothermic reactions are the one which will be coming in the type 2 reactions, which is decomposition, whereas all the combination reactions as I told are exothermic reactions where energy will be released during the reaction. Okay, so let's study about few more exothermic reactions which are not combination. Exothermic but not combination. So what is exothermic? As I told you, during a reaction, if energy is released, it is exothermic. Combination also produces energy, but it's not like every exothermic is a combination. Okay, it's the opposite. All combinations are exothermic, but not all combinations, not exothermic. All exothermic are not combination. Okay, all combination are exothermic. It's like opposite. Okay, so the exothermic reactions but not combinations. The first one is I think respiration. Okay, let's follow the same pattern in the textbook. They can explain about burning of natural gas as the first one. So what is burning of natural gas? It is CH4, which is methane. If combined with oxygen, it will form CO2 and H2O. Okay, so methane is gas, oxygen is also gas, carbon dioxide is also gas, and here it is H2O, but it is also in vaporous state, so that's why I'll also represent it as gas. And so let's balance it. Here 4 hydrogen, 2 hydrogen, so I'll keep it here. Now 2 oxygen, 2 oxygen, here it is total 4 oxygen, here it is 2 oxygen, I'll keep it 2. Now it is a balanced chemical equation. So here also heat is getting released when we are burning a natural gas. Okay, and the second one is respiration. I'll write it in detail in the next slide. So respiration, I think everyone knows what is respiration. So respiration is a process where we intake oxygen and break down the glucose to produce energy, and it also releases the outside, which is called carbon dioxide. So oxygen will enter into human body, and what will be coming out? Carbon dioxide, and the human also releases energy for himself. Okay, so oxygen is going in, carbon dioxide is going out. At the same time, energy also will be released, but it will be not exhaled outside. The energy in form of the energy which is getting created, it will be utilized by the body. So how this energy and what is happening, which is combining with oxygen to get carbon dioxide means, so whatever the food we are taking, food intake, for example, potatoes contains carbohydrates. Okay, so these carbohydrates, with help of digestive system, so digestive system chapter and all will cover in detail in that chapter, but now just understand, with the help of digestive system, these carbohydrates will be broken down into glucose. So this glucose plus oxygen will convert into energy and carbon dioxide as well as water. Okay, sorry, water will not be released. So glucose formula is C6H12O6. This is combined with oxygen to form CO2, H2O and energy. Okay, so let's balance this. C6 are present, so I'll keep 6 CO2, hydrogens 12, so I'll keep 6 here, 12 hydrogens, 12 oxygen, 12 plus 6, 18 oxygen are present. Here 6 are present, so it should be 6 oxygen with 6 2 is 12, 12 plus 6 18, 12 6 are done, so we have 12 more, so just if I keep 6 it becomes 12 oxygen. Yes, now it is balanced. C6 C6 H12 H12, 6 plus 12 18 oxygen, again here also 12 plus 6 18 oxygen. So here this is all example for exothermic. Why? Because in the conversion of oxygen and water at the same time energy is also getting released and this will be utilized by the body. Let the points here. This is glucose, this is oxygen, we know, carbon dioxide, water, I think everyone knows this. Okay, this is the second example for exothermic reaction. We have one more example for exothermic reaction, which is we don't have reaction, equation for it, but in the terms of theory I can say it is the decomposition of natural organic matter, so which is nothing but vegetable matter. So I'll write here decomposition of vegetable matter also releases energy. Okay, this is the third example. So this they can ask you, tell me few exothermic reactions which are not combination reactions. Then you have to tell these three reactions, which are, first one is burning of natural gas where methane is combining with oxygen to get carbon dioxide and water. Second, we have to discuss about respiration. So like whichever the food we are taking will contain carbohydrates that will convert it into glucose with the help of digestive system. This glucose will be combining with oxygen present in which we are getting inhaled during respiration. So those two will combine to form carbon dioxide, water and energy. Okay, and the last one is decomposition of vegetable matter. So this reaction also produces energy. So these are the examples for exothermic reactions which are not combination, and as I told you, all the combination reactions are exothermic because for every combination of two or more reactants to forming into a single product, energy will be released along with the product. Okay, where is the first example? Okay, this is a reaction where two or more, not only A and B, two or more if combined will produce a single product along with energy is called combination reaction. Okay, so I'll just give a definition about second and in detail we'll cover in the part 3 video. So what is the second type, which is decomposition reaction? So what is decomposition? You can simply say opposite of the first one, where two or more combine to single product, but here if a single reactant gets decomposed or breaks down into two or more products. Okay, now the symbol, I can say generic equation is A giving rise to B plus C is the example for decomposition reaction. So let's write the examples. First one, so in decomposition also we have three different types. We have thermal, means with the help of heat it is breaking, then it is thermal decomposition. With help of light we call it as photolytic decomposition, and with the help of current we call it as electrolytic decomposition. Okay, so we'll discuss about one by one. First example, with the help of thermal decomposition, as I tell you, if I keep ferrous sulfate and if we heat it, what will happen means ferric oxide will be formed along with sulfur dioxide and sulfur trioxide. Okay, so these are endothermic reactions because we have to supply energy, then only the reactant will break into multiple products. Okay, so this I will explain now. So for us, how we have to conduct this experiment means I will use different colors now. So first I will take a test tube. Okay, inside it keep ferrous sulfate crystals. Let's use this color. Okay, and let's use a burner below. So this test tube cannot be a stand like this, so with the help of stand we'll fix it. So I'm using a stand. So these two are connected to a stand like this. So what is the experiment? I have taken a test tube, I have kept ferrous sulfate crystals, and I'm providing energy in the form of heat. So what will happen after some time means from this outside we can feel that gases will be getting out. So ferrous sulfate generally it will be in green color. So what if you provide heat, what will happen means after some time we can see some gases are coming, and you can also sense the smell. Okay, don't keep your face directly to the test tube, but if you smell the part around here, you can feel a different smell will be coming, which is nothing but the smell of sulfur dioxide and sulfur trioxide. Okay, so how it is happening? Because of ferrous sulfate which is present in the test tube will get decomposed and forms ferric oxide, and at the same time two gases will be released which are SO2 and SO3, which are sulfur dioxide and sulfur trioxide. Okay, so which are remaining inside the test tube is nothing but ferric oxide, which is Fe2O3. Okay, so let's balance this. 2 sulfurs are present, I will keep 2 here. Ferrous 2, okay, oxygen 2 into 4, which is 8. 3 plus 2 plus 3, 5 plus 3, it is 8. So it is a balanced chemical equation where ferrous sulfate, which is solid, will decompose to ferric oxide, which is also solid, but SO2 and SO3 are gases which will be emptying outside from the test tube. And as we are supplying energy in the form of heat, this belongs to thermal decomposition. Okay, so there are two more types of decompositions which are photolytic decomposition, where light is supplied in the form of energy, and we have one more which is electrolytic decomposition where current is supplied as energy. Okay, so those two will be along with the other three types, which is displacement, double displacement, as well as redox and oxidations. Those will cover in part 3 video. Okay, so in this, as I mentioned, I will cover the types of decomposition, will also cover displacement, double displacement, and the last one, which is redox, which are oxidation and reduction reactions. I will be covering in the next video, and mostly only I think 2 more topics will be left. We'll try to cover it's a part 3, or else I'll give another part which is part 4, and there I will conclude this whole chapter. Okay, so mostly after completing part 4 I will prepare a live session where I will cover in-text questions along with the exercises, and I will also go through like a short revision of the entire topics which we are discussing in all 3 parts. Okay, so if you are interested to study part 1 video as well, I'll keep that link in the description, and let's meet again with part 3 video. Mostly tomorrow, day after tomorrow, I will make sure to complete part 3 and upload in the channel. Okay, so thanks for watching. So if you like this video, please do like and please subscribe for the further videos.